In this video, I want to talk about how to graph a piecewise defined function. So remember that a piecewise defined function is a function where we have different rules for different domains or for different chunks of the domain. So in this case, the function is x squared if x is less than 0, 4 if x is equal to 0, and 2x minus 3 if x is greater than 0. So the way to graph a piecewise defined function is one piece at a time. So I'm color coding them just so that you can see more clearly which function is which. So let's go ahead and start with the orange piece. So x squared if x is less than 0. So that means that we're dealing with all the domains over here in this region where x is less than 0, so nothing over here. So x squared is a parabola, so I'm going to graph a parabola, but only where x is less than 0. So when we have a less than that doesn't have a less than or equal to, a strict less than, we're going to use an open circle on our graph for that point, because we go all the way up until that point, but we just don't get there. So we're going to use an open circle at 0, because 0, 0 would be the first point on that parabola, right? X squared, or 0 squared is 0. So now negative 1 squared is 1, and negative 2 squared is 4, and this should look pretty familiar from other parabolas that we've graphed. So I'm going to do the best I can here. Okay, so this is x squared if x is less than 0. So it starts with an open circle at 0, and then I'm graphing this half of a parabola, which is x squared, right? If it was over here, then it would be the full parabola, but it stops when x is equal to 0. Okay, now the next piece just says that f of x equals 4 if x equals 0. This gives us the point 0, 4, and that's it. So 1, 2, 3, 4, because we have a single value for x, and a single value for x is 0, and a single value for y is 4. So it just gives us a single point. Okay, now we can move on to the green part. So this one says that f of x is equal to 2x minus 3 if x is greater than 0. So 2x minus 3 is a line, right? It has a positive slope and it has a y-intercept of negative 3. When we go to negative 3 to do our y-intercept, we need to remember to do an open circle because it doesn't include 0. It's just greater than 0. And then from here, we can use this as the first point, and then for our slope, we need to go up 2 over 1. We can do that again, up 2 and over 1. And then use the ruler here. Okay, and that is how you graph a piecewise defined function. So you just graph each part only on the domain that it's supposed to be. So x squared if x is less than 0, so we did that for everything where x is less than 0, 4 if x is equal to 0, and 2x minus 3 if x is greater than 0.